So we are going to discuss about cluster analysis. In K-means algorithm, we have seen that K plays a very important role, because if we give a wrong value for K, then the cluster, whatever the clusters form, you cannot say that they are the accurate ones. So it should be very careful that while selecting this value, right? Okay. In this particular slide, you can see we have selected K is equal to 2 to arbitrarily partition objects into K groups, right? Then update the cluster centroids like this, then reassign the objects, then update the cluster centroids. Means what? Every time we are trying to update the cluster centroids in each iteration, means whenever we assign the objects, after the object assignment takes place, we try to find the mean, right? Compute the mean. Then if the mean value is okay, the same as the earlier one, then it is okay. This means we need to stop this process. Otherwise, if it changes, then we have to take the new mean as the centroid, and accordingly we find out the distance of each point to the current mean, right? So whenever the distance of a point, data point, say x1, is less to cluster C1, but earlier it belongs to cluster C2, now it should be assigned to C1, because distance from that of that data point x1 to that particular centroid C1, mana cluster 1, is less. Okay. So you can see here, compute centroid, that is mean point for each partition, assign each object to the cluster of its nearest centroid until no change. So first step is partitions objects into K non-empty subsets. Then we compute the centroid, right? And then we assign each object to the cluster of its nearest centroid. And this process will go on until no changes. Means suppose the centroid, whatever found in the current state, is same as the earlier one, then we have to stop. Then we have hierarchical clustering. So hierarchy, hierarchy means what? Whenever we follow tree pattern, then that becomes hierarchical. So here we use distance matrix as cluster criteria. This method does not require the number of clusters. See, in K-means, in partition clustering, we require the number of clusters as input. But in case of hierarchical clustering, we don't want that. But we need a termination condition. So hierarchical clustering में हमें क्या चाहिए? One termination conditions. So this is how it differs from the partition clustering. While partition clustering, we have to find out the value for K, and K means the number of clusters. But in case of hierarchical, we don't need to find out that number, but we have to find out the termination condition. Now, it is basically two types: agglomerative, okay, and divisive. Now, agglomerative means what? You can see that here we are starting from for this curve. Just let me show you. This is the curve for agglomerative, right? Just a minute. Okay, this is the curve for agglomerative, and here step zero, just a minute. Let me. Step 0, step 1, step 2, step 3, step 4. So in the step 0, if you can see clearly, this is what is that. Just 1 minute. In the step 0, we have these points A, B, C, D, E. So all the separate points are now we are considering as separate cluster. Then in the step 1, we are merging A with B, that is AB becomes 1. And in the step 2, we are merging D. And in the step 3, we are merging C with D, CD. And in the step 4, we are merging CD with AB, ABCD. So that is what agglomerative is. ठीक है, तो हमने पढ़े एक एक डेटा पॉइंट को एक एक क्लस्टर मान के स्टार्ट किया, राइट, बाद में जाके उसको मार्च किया. सो दैट्स अ काइंड ऑफ एग्लोमरेटिव. तो आप देखोगे तो एक किस टाइप का अप्रोच है, ये बॉटम अप टाइप का अप्रोच है. नाउ in case of divisive, what happens, we consider all. Now divisive is this side. Let me, okay, this one is the divisive one, right? This is the step 0, and in the step 0, just let me choose one different color. In the step 0, we have all the data points inside one cluster. ठीक है, डिविजिव ने हमने क्या किया, A B C D, every data point we are considering, we are keeping in one cluster. Then gradually we break or we separate those data points from one cluster to two clusters, means we are dividing the clusters, right? And ultimately we stop when no more growth is happening, then we stop. So divisive, in divisive, this is opposite to our means this one, agglomerative. In divisive, we consider all the data points inside one cluster, and it goes on until we break each of them into separate clusters. Okay. Okay. Now let me clear all the screen. ठीक है, कुछ नेटवर्क प्रॉब्लम आ रहा है, सॉरी फॉर इट. Clear all drawings and close. Okay, ठीक है. Now next, अब जो distance between cluster, in case of hierarchical clustering, it is very important that distance between clusters you need to find out, right? Even it is important in every type of clustering. Now basically we are talking about the hierarchical one. In distance between clustering, like single link, smallest distance between an element in one cluster and an element in the other. Like see, distance between ki and kj, minimum of tip and tj. So smallest distance is known as the single link. Smallest distance between an element, ये एक क्लस्टर है, इसका एक कोई भी एक एलिमेंट और कोई दूसरा and an element in the other cluster, then that smallest distance is known as the single link. Okay. Similarly, complete link. Complete link is the largest distance between an element in one cluster and an element in the other. So yeah, we have to consider the max. Remember, single link, we are considering minimum, and complete link, we are considering maximum. Then average means what? Average distance between an element in one cluster and an element in the other. Then centroid, distance between the centroids of two clusters. Medoid or medoid, distance between the medoids of two clusters. Now, whatever you are choosing, centroid, medoid, this should be the what? Actually, this is the representative of that cluster. Medoid is chosen centrally located object in the cluster. Okay. Now, this is clear. Okay. Now, what you do, you just take a screenshot of this, right? Basically, here we are trying to form one grouping from the given values. Tree structure, CF1, CF2, CF3, CF6. They are the siles, sile 1, sile 2, sile 3 up to sile 6. Then non-leaf node, right? Then leaf node. So means what? In a tree, we all know about the tree data structure. Ultimately means at the bottommost position, we have the leaf nodes. If leaf nodes are there, then this means what? No growth, no further growth is possible. We have to stop right there, right? And non-leaf node means what? It can generate the child. So once child is generated means what? It may be either what? It may be either left side or right side like that. Okay. But in case of leaf node, it is that's what? It is just linking with the other leaf node. It is not growing further below. Okay. Okay. Now, it is not so important, but still, you can note down about KNN. KNN and KNN means what? K nearest neighbor. This is one very famous algorithm in the case of classifications. Basically, for classification of our supervised learning case, we use the K nearest neighbor. Right. Now, this has similarity with k-means clustering. K-means clustering we have discussed, right? In case of k-means clustering, we need to select k. Like similarly here in k nearest neighbor, we need to select the nearest neighbors. Okay. So this is about KNN. Basically, if possible, because time is very less now, I will take one class on KNN also. Just 1 minute. Just okay. Okay. Now, density based clustering. কোন নাম ফেজিল স্যার ভিতৰত আছে এইটো ভিতৰত কেবিনত